Hi, welcome back. So in this session, we'll just be doing some rounding up. Let's complete the to-do CLI with the delete functionality. So let's create the flag. So this flag is going to be an integer, just like the complete flag. It's going to be receiving the position of the to-do item. So we create the flag. Flag is an integer. The default value, the flag name is delete. Default value 0 and the description of the flag. So we include the case in the switch statements. So we check. Remember to dereference your flag before using it. So we check if the delete is greater than 0. If it is, then something has been specified. So we call the delete functionality and check if there's any error. If there's an error, we print the error in the standard error output from the OS package. And would exit with 1, just as we've been doing. And next up, we're gonna save the updated lists. Alright, so let's test our delete functionality. Okay, there's an error. Oh, it's the type integer, so just a typo. Let's go back to fix that. Alright, so let's put that to the 0, not to the integer 0, not to the string 0. So let's run our test again. Alright, so it's working. Let's test our delete functionality by passing the first. Okay, so it's deleted the first to-do item. So it's reflecting in the list on read time. Yep. So looks like everything is working as expected. Let us add the task. Alright. So our previous functionality still works. Nice. Alright, so that does that. Let's now build our to-do CLI. For every application you build, we will need to run it in several environments. So it's very simple. We just need to run the build command. So by default, when you run the build command, it builds for the operating system you are working on. On my case, it is Mac. So I can then call the build file rather than calling the main.go file again. So it's working just like you're calling the go run command on main file. So that is us calling the tool rather than calling the go.run command. So it works perfectly just like you're running it. So now I want to build for our Windows operating system. So like you want to build and make it portable. Oh, okay, there's a missing an S. Okay, let's change that. Alright, so it's going to generate a .exe file that can be executed on the Windows operating system. So you can go ahead and test that on your side. So next up is the usage. For every tool CLI, I want the user to know how to use a CLI tool. So by default, the flag command would give you the basic usage functionality, but we can customize it. We can make it look more presentable. So it gives you the usage of the tool even if you send in the wrong flag. So it gives you the usage that this is how to use the tool. That is when there is in a flag functionality in your CLI, but we can customize that. We can make it more presentable. So let's do that. So let's customize our flag. Right. So the flag.Usage command takes a function, and that function contains everything we want the usage functionality to print. So it's gonna take a writer, the io.writer implementation, which is a flag.commandline.output. So and it's gonna take the message that you want to display. So remember the fmt.f.print takes an implementation of the io.writer interface, and in this case we are passing in the flag.commandline.output since we want to use it in our usage functionality. So you can put as much information as you desire in this section, format it the way you like, and after everything you don't forget to print the default, which is very, very important. So you can put everything you want in this section, and next is just to print the default when you're satisfied. In my case, I'm satisfied, so I put the default. The default is what we had before. So let's test that. We build a file and we run it with the h flag, which is the default usage. So it has everything that we want, but we need to make it more presentable. So the new line, yeah, makes sense, but it still needs something. Yeah, let's add a new line there as well. Right, so let's build and let's run with our h flag. Okay, so everything is now working as expected. You can customize it to your taste, and yeah, it works. Next up is working with the environment variables, and in this case we don't want to hard code our file name. We just want to use that to be able to specify the file name that you want to store your to-do items. So you can do that by reading the environment variables on any operating system you're working on. So in Go, the way to check for environment is the os package, os.Getenv. We check the file name, or probably the variable that we've defined. In my own case, it is to-do.filename, and I'm checking if it is specified, or if it is not empty. So if it is not empty, we set the file name to the file name that has been defined in the environment. But if it is not, it returns the .todo.json file name that we specified. Alright, so let's test that. Okay, so let's export our file name. I'm gonna call it what should I call it? Let's call it the new to-do file name. Alright, so we've exported that into the environment, and let's run that now. Automatically the os.Getenv will pick it up. Alright, so let's run it and let's see how it performs. Alright, let's create a task to see what is going to be generated. This new task to file name on environment. Alright, so let's see what's going to be generated. Alright, so the new file name is generated automatically, is created, and to those other shades, let's add more task. Alright, so it's working as expected. Let's test other functionality. Yeah, works. Yeah, let's complete the task. Also works. Nice. Thank you very much.